solving a geometry word problem for linear modeling. Let's read this step number 5 and see how we can work on this. So typically in here we'll be dealing with solving lines parallel or perpendicular to a given line. Let's call it L1. Passing through a given point, let's call that one X2, Y2. Okay. Aspen, let's read that question number 5. Thank you.
Find the area of a parallelogram bounded by the y-axis, the line x equals 3, the line f of x equals 1 plus 2x, and the line parallel to fx passing through 2, 7.
Thank you. All right, let's circle the numbers first. So the numbers in here, x is equal to 3, right? That's a line. Okay, x equals 3. What kind of line is x equals 3? A vertical line. Very good, right? With the passing through, it's x-intercept at 3. Very good, that's correct. Rachel. Next one, f of x is equal to 1 plus 2x. All right, there we go. What else? Ordered pair, 2, 7. It's passing through that one. Okay. Let's see. Let's underline the question. So what do we need to do for this case? Find the area of a parallelogram bounded by these graphs, okay? By these equations, okay? Correct. Next, let us box the keywords and phrases, all right? Brooke, what are the keywords and phrases in here?
I'm gonna go with
So first, what do we need to find first?
okay, the y-axis. Or well, the parallel to you want okay.
So yeah, the parallel. What else?
Parallel, and then passing through or fx passing through.
What is x equals 3? Is it like a curve, a triangle?
It's just a line. There
It's
you
a line,
go.
right? You can verify that one as well, right?
Yeah.
What is 2x plus 1?
Oh, another
It's
line.
another line. Very good. What are we looking for? Area. Very good. And what shape are we looking for? Parallelogram. Get it? Right. Are we good, guys? Right. Now, let's make an equation out of it, right? So, let's deal with the equation first. So, here it is. And using these values, let's use this series of steps on how to solve for this one, right? And our series of steps in here, it says how to determine line parallel, right? Or perpendicular, depending on what is given in our case. Parallel. To a given line, let's call it L1, passing through a given point, let's call it X2, Y2. Okay, let's read our step number 1. Adam.
L1 is a slope-intercept form.
All right, so is our given line in slope-intercept form? What's the given line? F of x or y is equal to what? 2x plus 1. Is it in slope-intercept form? Yes. Yes. Very good, right? That is correct. With that being said, what is our slope? M1 equal to? 2. Very good. That's correct. Rachel. So check on step number 1. And step number 2. Let's read step number 2. Corey, go ahead.
Find slope M2, A if parallel, M2 equals M1, B if
Perpendicular.
intersect.
Perpendicular? Yeah.
Okay. M2 equals negative 1 over M1.
All right. So is it case A or case B, Corey?
A.
A. Very good, right? And with that being said, therefore M2 is equal to how much, Frank? 2. Very good, right? Since they're parallel, then that means, right, there's the symbol for parallel, they're of the same slope. Okay. Step number 3, right? How do we answer step number 3? Welcome, Jonathan. Go ahead.
Point slope form.
Thank you.
Line 2.
And what's the formula for points law form? Y minus what's our point, by the way, here? What's our point? What's our x2, y2? Passing through what values? 2, 7, right? So that's one. Y minus Hampton.
Y minus
7, very good. Is equal to? 2, very good. Parenthesis, x minus 2, very good. Get it? Points law form, right? Okay. Solve for y if you need to, right? I think in this case we don't need to solve for y, right? But if you need to, you just need to what? Distribute 2 in here, right? And then add 7 on both sides after that, right? Again, if needed, right? But if it's not needed, that will be fine already, right? And the last one, verify by graph. Are we good? Right? So check, we have solved for the equation already, and that will be it, right? Y minus 7, 2 parentheses x minus 2. Let's verify everything by graphing. And here it is. Okay, let me just go ahead and X this out. What's the given line? Y is equal to what? 2x plus 1. Good, right? What's the given point? 2, 7. I'm going to zoom in just to clearly see it. Good. Right. And what's the given equation? Well, what's the equation that we got? Okay, y minus, so in here it'll be fine if you just put it in here in a points law form. Okay, good. No need to solve for y. Again, if it's not needed, you can just basically graph it there, right? So as you may notice, the 2x plus 1 and the equation that we got is parallel and passing through 2x plus 2 and 7, right? What else? It says in here something on x equals 3 and the y-axis. Are we good? Right? So where are those? I'm gonna put in here x is equal to 3 as well. You see that vertical line here in blue, right? Okay. I'm gonna zoom it out once again, just to clearly see it, right? And where's the y-axis? This y-axis, right? I would put in here just x is equal to 0, just to highlight where the x-axis is. Are we good? All right. So, let me go ahead and draw it in here like such. Annotate. So, where is that parallelogram that we're talking about? This is the parallelogram. The question now is, what is the area of that parallelogram? Are we good? So we have to deal with a little bit of a trick, geometric trick, just to answer this one, right? In order to answer this one, to get the area of a parallelogram, I'm gonna analyze it like such, okay? So ready, guys? To get the area of that parallelogram, okay, then that will be equal to, first, I'm going to consider first this rectangle, this whole rectangle here. See that whole rectangle? All right, so that's one. Okay. If I get the area of that whole rectangle, right? And then what else? I'm gonna consider the what? The area of this what? Triangle in here, right? You see the triangle, right? Okay. We good? What can you notice about this triangle below and that triangle above? They're basically the same congruent triangle, right? So in short, I'm just gonna do this one. Double this. Get it? Right? So the area of this rectangle, and then twice the area of this triangle, right? Triangle in fact, right? Then what do I do to these two? to get this?
Minus it.
Subtract. Very good, Corey. Right? Get it? So let's do that one, right? Let's get first the area of that rectangle, right? And how do we do that? Well, visually, you can see it in here. I'm going to color it red once again. What's the length of this rectangle, right? What's the length of that rectangle? Well, you can just basically count it. 0, right? 0, 1, 2, 3, 4, 5, 6, 7, 8. Get it? So that's 8 units length. Okay. Now what's the width? What's the width of this rectangle, right? Let's call it W, or the width of the rectangle. 0 once again. 1, 2, 3. Right? Now with that being said, what you're going to do with 8 and 3 to get the area?
Length times width.
Length times width. Very good, Edward. So what's that going to be? What's 8 times 3 equal to? 24, right? So that is 24 square units. Good. Okay. Get it with the rectangle? Let's go back now to the triangle itself, right? For this triangle, I'm going to color it blue, right? This triangle in here, first of all, the area of any triangle is equal to what? Half base times height. Very good. That is correct. Now, with that being said, what is the base of this triangle? What's the base of this triangle? This one.
1, 3.
The same as the width of the rectangle? 3. Very good. That is correct. Get it? Okay. Now, what is the height? Okay. What is the height of that right triangle? Let's count from here to there. 0, 1, 2, 3, 4, 5, 6. Get it? Okay. So that means this is what? 6 units. Okay. Okay. Combining those two, so what is the area of this right triangle in here? 1/2. What's the base? 3. Right. What's the height? 6. So how many square units will that be? So make your calculators useful. Jeremy, what you got? 1/2 of 3 times 6.
I didn't do it yet.
Okay. Oh, calculator. 9 square units. Very good, Rachel. There we go. Square units. Again, specific with the area, it's always square units, right? Square inches, square meters, square centimeters, square feet. Okay? So put in here what? And you're going to what? Double that one, right? So I put in here what? 2 times, what's that? 9 square units. Are we good? Okay. Now what do we do with these two? Subtract them. Okay. So what's gonna be the final answer, right? What's the area of that parallelogram? By once again, getting the area of that rectangle, right? Getting the area of this triangle, formula, half base times height, doubling it because the one bottom and the one on top are just the same anyways, and subtracting them too. Okay? Okay, what you got as an answer? Nista, you got an answer already? What's that for? Anyone? Got it. Sean?
6.
6. Very good, right? Square. Yes. Good. So, hence, we got the area of that parallelogram here by once again visualizing it, right? This is a good application of, I know there are a lot of you guys who are into engineering and associate in science, so you'll be dealing with a lot of geometry as well for those courses, all right? Any questions regarding that one? Seeing these applications of our knowledge of linear equations, both parallel and perpendicular, in this case parallel, in a geometric perspective, right? Once again, obviously you have to know that the formula for area of a rectangle is always length times width, and the formula for area of a triangle is 1/2 base times height. And again, it's in here, the base and the height should always be what? Perpendicular to each other. In short, they should be at 90